starting now. Hello, today we're going to talk about common software defects. In the previous talk, I mentioned code smells, and the classification and recognition of code smells can help engineers identify bugs earlier in development. As someone who has made a lot of mistakes in software, it becomes apparent that the use in specific tools tends to bring along specific software defects. And those software defects tend to have specific smells. When we encounter bugs, we like to discover them in development rather than production runtime. And even better is finding bugs at compile and build time rather than at runtime before any bad code could be run. But truly, the best approach to avoiding software defects entirely is to not have them in the first place. Because indeed, using fewer tools, libraries, and languages in our software development reduces the number of opportunities for software defects to occur. And if the stink of software defects is not recognized, even minor mistakes can be turned into software vulnerabilities. It is unfortunate, but we live in a world where if we fail to learn from our mistakes, they will be weaponized against us. Villains in this world can get ahead by exploiting otherwise mundane weaknesses in software. Indeed, there is a multi-billion-dollar dark industry around the distribution of 0 days, software defects that are as of yet undiscovered and unpatched, and whose short shelf life can be used as the fissile material of cyber weapons. Software defects left untreated will be turned into vulnerabilities when interested counterparty discovers how to exploit it. I recognize 3 significant groups of code smells, and all of these are based around the handling of state. Bugs of mutated state, bugs of unstructured state, and bugs of shared state, or how I think about these defects. And I intend to give presentations on each of these later. But I find that these smells tend to stink in similar ways and tend to come from the use of similar tools. But this presentation is concerned about other more common code smells than these. Code smells such as copy pasta, where a developer copies code from an existing segment of work, or text or scaffolding, and forgets to fill out the details or change the edits. It's recognizable because it has that usual source of origin. I know I read that somewhere. Reusing existing work is a central part of software development, if not our lives. And so this can emerge in our documentation, communications, really anywhere we are too lazy or mistaken to fill in the words. It is easy to make this mistake, and especially if you are rushing. So reviewing your code or documentation of peers helps before submission. Copy pasta bugs will even percolate typos and can inhibit DRY code. Do not repeat yourself. Copy pasta bugs will even percolate typos and can inhibit DRY code. Do not repeat yourself. Magic numbers are another common occurrence in software development. They could be immensely misleading. If left unchecked, like 2 rabbits in a hat, magic numbers can start to multiply. Also, like 2 rabbits in a hat, they have a distinct smell. Because magic numbers are significant numbers, strings, or other constants that are not constants. They're just in the code doing their thing. But of course, they're not constants. They're repeated and inhibiting of our DRY code. In addition, magic numbers can make refactoring of code challenging. They misdirect developers and they do not convey programmers' intentions. Another recognizable smell is arbitrary brackets. Yeah, the first element of a list may be at 0, but what if the list is empty? If you refer to a named constant in a map, that map better have that key. Magic numbers encourage arbitrary array or map access, and that arbitrary array or map access is reaching to the hat and pulling something out. That something could be a rabbit, or it could be an index out of bounds error. Naming problems. What's wrong with this little bit of code? Well, it's in the name. It doesn't double, it multiplies by 20. This function does not say what it does, it says. It lies, and that lie will lead to bad decision-making and developer confusion. And so it is on us, the developers, to choose names that are explicit, grokkable, consistent, meaningful, pronounceable, intentional, and namespaced. Names for our variables, functions, and classes. Naming things is indeed tricky. After all, it is one of the 2 hard problems in computer science. No silly or single character names either. Good code, well written, can read like English, and comments in code seemingly only get in the way. And by the way, enterprise code audits will look for swear words in code, so none of that nonsense either. And dependency issues. These can emerge when the underlying software has been subjected to significant code rot.
1 minute.
Unmaintained code can probably run a lot longer than you'd think. But open source software that interfaces significantly with humans or is labeled pre-1.0 by its creators tends to rot much faster. Vulnerabilities can be easily detected by scanning project log files and comparing source software versions with known deprecations. And by the way, this is why you should always check in your package manager generated log files to version control. That's the receipt for your build system dependencies. And this is a great example of why programmers will never be automated out of a job. Because the castle of cards of network computers and linked libraries is forever teetering. And so much of the internet is built by dedicated engineers who could instead be spending time having or playing with their children. Thank you. That's my presentation.